Hi everyone, welcome back to Physical Science Online. This is Ms. Vukovic on behalf of our physical science team, including Ms. Lackey and Ms. Barnes. This week's concept is going to be covalent bonds. For this week, we want you to be able to do three things. We want you to be able to explain how covalent bonds form. We want you to be able to name covalent compounds. And we want you to be able to write a chemical formula. Just like last week, I am going to go over examples on your activity for the week. So if you have the worksheet out or the Google form, feel free to follow along. All right, let's get started. A covalent compound is one that's formed through the sharing of electrons. When two atoms share their electrons with each other, they complete their electron orbitals and they create a bond. Elements that form covalent compounds are nonmetals. This is the entire right side of the periodic table. A nonmetal and a nonmetal share their electrons. So because of this, when we practice, there's going to be no charges involved and no cross and drop. If you take a look to the picture on the left, you'll notice that there is two hydrogen elements. Those two atoms each have one valence electron. However, when they form a covalent bond, what happens is they mutually share those in order to complete your valence electron shell. Two skills that we're going to have to learn are how to name covalent compounds and how to write covalent compounds. When we name covalent compounds, it is very tricky. We have to use something called Greek prefixes to tell how many atoms of each element are sharing their electrons. The Greek prefixes are listed to the left. Mono is for 1, di is for 2, tri is for 3, tetra is for 4, penta is for 5, hexa is for 6, hepta is for 7, octa is for 8, nona is for 9, and deca is for 10. When we name covalent compounds, the first element has a prefix in front of the name. However, we do not write mono if there's only one. For the second element, we write the prefix in front of the name, but the name is written as the stem plus IDE. That's the same as our ionic compounds, just with the prefix in front of it. For your second element, you do write mono if there is one. All right, so naming covalent compounds. Like I said, we have to use our Greek prefixes, that's what's new, and we have to use our stems. We already know how to do that. For example number 1, you have a chemical formula of H4C. Let's start with that C because that one has a lot of tricky concepts to it. C stands for the element carbon. We know because it's the second element, we can't just write carbon. We have to write the stem first. So, we know that carbon is going to be carb with IDE at the end. So carbide. Then we can look at the first element, that H. H stands for hydrogen. Hydrogen gets left the same way. We don't do anything to the name. However, we do have to add those prefixes in front of both of our element names now. So we're not done. We have to look at the subscripts of the chemical formula to figure out what prefix we're going to write. Hydrogen has a 4 as its prefix. So we have to use tetra in front of hydrogen. So we just write that in. Tetrahydrogen. Notice the C doesn't have anything after it for a subscript. But since the letter's there, we know that there's one. So we have to use mono in front of carbide. Our final answer is tetrahydrogen monocarbide. All right, the last skill that we want you to be able to do is use the names of covalent compounds to write the chemical formulas. So we're working backwards now. I think this is a little easier, so we'll give it a shot. When we write chemical formulas based on compound names, the prefix becomes the subscript. We don't write ones, and we cannot simplify. Greek prefixes stay the same, so we don't have to learn anything new. Let's practice. I think we might be better at this part. All right, so we've got our Greek prefixes, we've got our stems, and we have our covalent compound names. Things we need to remember. If it's the first element, one would have mono, but that's not written there. So like that is not going to ever be a thing for the first element. When we look at number 1, this is exactly what I'm talking about. Nitrogen doesn't have a prefix before it, which means that there's only one of them. So we just write the symbol N. Then we look at our second element and we see that it's oxide. If you're confused, locate the stem and then you can find the element symbol. So oxy, that must be oxygen. So we can write in our oxygen next to it. Our oxide has the prefix mono in front of it. Mono stands for 1. We could write the 1 as a subscript, but that's not the correct way. So instead, it's just the chemical formula NO. I know there are a lot of rules, and we know that you're learning this online. So if you write the 1, it's not the end of the world. We're okay. We know what that means. But we want to get into a habit of not writing those 1s if you can. So try your best. I'm going to do number 2 with you as well. Disilicon trioxide is number 2. Again, figure out what elements we're working with. Silicon and oxygen. And you can write their symbols, leaving space for the subscript. For silicon, we see that there is di. We locate that, and that must mean that there are 2 silicons. So we write 2 as a subscript. For oxygen, we see that there is tri as our prefix. Locate tri, and we know that there are 3 oxygen atoms, so 3 becomes our subscript. We cannot simplify, and we just leave it as is. All right, you guys. So the main takeaway for covalent compounds, we are sharing electrons. 2 different elements have as many atoms as they need, sharing electrons to complete their orbitals. It makes them stable, and we're happy with that. We need to know our Greek prefixes because the Greek prefixes are directly related to how many atoms of each element are in our compound. Use the Greek prefixes, use the stems, and you'll be able to write covalent compound formulas and name covalent compounds. Practice on the Google Forms. Email if you need any questions answered, and we're here for you this week. All right? Have a great week. We miss you guys. And that is all.